Hello and welcome to my little presentation about magnesium. So magnesium is a chemical element which is number 12 on the periodic table. Magnesium has a atomic mass of 24. As you can see right here, we got the shell model for magnesium. It has 12 protons and 12 neutrons. And in its first circle, or first shell, we have 2 electrons, and then in the second shell, we got 8, and then in the last and third shell, we have 2. When you can see that in this outermost circle, it does not have 8, it means it's unstable because it does not fulfill the octet rule. When you look at it, we can see that it has the numbers or the name Mg. So there's only one atom, which makes it a pure element compared to when there's multiple and just an atom, and compared to when we have 2 as oxygen, it got a 2. Which makes it a molecule and not a atom. And when we take CO2, it is a molecule, but it's not a pure element. Oh, that has to be a capital right there. Then there's 2 types of atoms in it, which makes it a non-pure element. So the element magnesium has 2 other isotopes. It got the magnesium 24, which is the one itself because it's the atomic mass. Then it got the magnesium 25 and 26. The difference between all these 3 is the numbers of electrons. The magnesium 24 is the one we see right here, which has in total a atomic mass of 24, while the and 12 electrons, while the magnesium 25 has 13 electrons, and the magnesium 26, if you could have guessed it, it got 14 electrons. We can see that when you see on the shell model, it has 2 in the outer shell, or the third shell. Then we know that if we take this periodic table, then we can see we got it right here, which is number 12, that it wants to become neon, which is a noble gas. And it's the closest one. Instead of getting 6, it can give 2 away and become neon. With that, it wants to give away 2, and then it becomes magnesium 2 with a positive 2 charge, which makes it a atomic ion. Let's say better ion because there's only one atom in it, and it's not 2 ions. Now I actually want to show you the video or the experiment I've chosen for you to see, where I can tell about. We got the link right here. I'll just copy it in and we pause it. So right here we have the magnesium, which you can see is wrapped up. Now he's just talking about the reason why we can see it's metal. It's shiny, it can conduct electricity, it can conduct heat. So now he's going to show you how we're gonna see a reaction between these 2 atoms, the magnesium and the oxygen. he's going to light it up, or put it up so you can see it, and then he's going to put some activation heat or activation energy by heating it up, and now we can see it's really giving off this beaming light, this bright light. It's actually one of the brightest lights you get from a reaction or from an experiment, and it's because when we look at this, we can see that it create this kind of bond, or this string, which is actually very fragile. After this, he's going to touch it, and it's going to just fall apart immediately and just crack and shatter. So when we go back, we can see right here I've put up the chemical equation right here. So we got the two reactants right here. We got the magnesium, and then we got the oxygen. This we just saw here is what the product is, the magnesium oxide, as we can see here. So because it wants to become neon, which have these, which has 10, it wants to give away 2. And we got oxygen right here who wants to take, who also wants to be neon, because it's the closest noble gas, which is the only elements that won't change itself when reacting. So oxygen wants to become neon, so it wants to get 2 more electrons, and that would magnesium gladly give away. So it becomes neutral and becomes the MgO, the magnesium oxide, which is an atomic ion. So the way we use this magnesium in our daily life is we use it, as you saw here, the really bright light. The way we use it is that we can also make it react with oxygen in the same way, but at like New Year. We use it with fireworks and all these explosive things that's going to be pretty and all that stuff. The small, the small star throwers, I don't know what to call them in English, which also make this beaming light. So, and we also make it in our diets.